T3, Day 15 of Calculus. Today we're going to continue our discussion of antiderivatives. We're going to start by evaluating a couple integrals. The first one is indefinite because it has no limits of integration, so it'll have x in it. So there's no limits here. You're not evaluating it at a specific between two specific values, but over here this is definite, so we will. So in this case, everything's kind of broken up really nicely for us. We don't have to simplify anything, although it might be nice to rewrite that last term. So if we want to rewrite it once before we get started, it'd be helpful. I would rewrite it like this, negative 3x to the negative 3 dx. And you just need to be careful that you apply the same rule over and over again. So what's this going to be? Well, it's going to be x to the fourth, 1 power up from 3. And that 4 is going to go down there, but that 2 stays. So we do this out before we simplify. So that's going to be minus 5 over 3x cubed plus, what's x squared over 2, and that 4 stays there. Remember, we go up a power. We go up a power. So that's going to be plus, or excuse me, minus x is going to the negative 2, and it's going to be over negative 2, and that negative 3 stays there. You don't need the two negatives there. I've done 2 of them. We already did the minus once. So keep in mind that 3 stayed the same like it was the case in all the other places. And then this power went up by 1, just like the other ones, but then it also then had to go down there to cancel out. So you could simplify this to be 1/2 x to the fourth minus 5 over 3 x cubed plus 2x squared plus 3 over 2 x to the negative 2 plus c. That c is really important. That constant needs to be there. This would be a great final form right there. So we're going to do the same thing we did before, but this is a definite integral, so we need to evaluate it for and at negative 2. So when we do the indefinite integral here, let's just go down. It's going to be x cubed. So that 3 is going to go there, and that 2 stays the same. So that 2 marches down there. And then you end up with plus 4x plus c. We can put the c in there, and let's see what happens to it. And you're evaluating this from negative 2 to 4, meaning you got to plug in 4. So that's going to be 2/3 times 4 cubed plus 4 times 4 plus c. That right there is this with 4 plugged in. And what are you going to subtract from it? The same thing, but instead of 4 getting plugged in, you're going to plug in negative 2. You got to be careful with these negative signs. So it's 4 times negative 2 plus c. And you see what happens to the c's? You have c minus c. Those cancel out. They're gone. They're gone. So when you evaluate this, you got to be careful with the fractions. It does come out to be 216 over 3. So let's find the exact area between the x-axis, and that curve over the interval negative pi to pi. So let's do this exactly. So pi will be in our answer. What does this look like when you graph it? X squared minus 9. X squared minus 9, it's going to go down, it crosses here. It's going to be negative 9 right there, and here's the x-axis. So what area are we looking at right here? We're looking at this right here. We're looking at that right there. So where's pi? Pi is going to be, this is going to first use a 3 and 3. Like what makes that 0, 3, and negative 3? So if we're going from negative pi to pi, actually negative pi is a little bit to the left right there, and positive pi is to the right there. So if we want to find the exact area between the x-axis and the curve, so since it's asking us for the area between the x-axis and the curve, we need to make sure we're really careful because it's always going to be positive because it's asking for the area between the x-axis and the curve. So at some points it's above and at some points it's below. So what we've done in the past is we've done an absolute value of this thing, meaning we've done the absolute value from negative pi to pi of the absolute value of x squared minus 9 dx. And we can also break that apart though. We know it's going to go from negative pi to negative 3 right there, so it's negative pi to negative 3 of the original function like this. So for the first one, it's just the original one from negative pi to negative 3. But for the negative 3 to 3, we have to, the upper function becomes this y equals 0. So what are we going to add to it? It's going to be negative pi to pi of 0 minus x squared minus 9. And then we also can make this a little easier on ourselves because we know that this right here is the same as this right there, even though my picture isn't perfect. It's symmetric. So we can just put a 2 out front and double it. So what does this mean we're evaluating? We're evaluating 2 times negative pi to negative 3 of x squared minus 9 dx. And for here, we're doing negative pi to pi of, distribute that negative right there, negative x squared plus 9 dx. So we can do this out. It's going to be the same antiderivative in both cases. So it's 2 times, it's going to be 1/3 x cubed minus 9x from negative pi to negative 3, and it's going to be 2 times that. And for here, it's just going to be negative 1/3 x cubed plus 9x from negative pi to pi. And remember, the reason this is happening is because the upper function was first here, and then it goes straight across. That's 0, so that's why it's 0 minus that. Before, it was just the regular x squared minus 9. So when we do this out, first we're plugging in negative 3 into all of these x's. So we've done negative 3 and negative 3 right there. And then we're plugging in negative pi in the same places right there. Now it's just you have to be really careful with your algebra. If you clean this up, it's got to be careful with fractions. So you can see what I've done here. Tried to group things up. Those two become positive, that becomes negative. I'm trying to get a common denominator right here and right here. So it can to this right there. And now we have to do one more here. We have to do this one. So that's just the top one right here. We have this. And now we have to do the same thing over here. We have to do the same thing over there. So what does that look like? It's got to be really careful with the negative signs here. So when you combine all this, you get negative 2 pi cubed over 3. That's these two. Plus 18 pi. So that's this right here. So now that's that one. So now you just need to group these two together right here. You need to add them together. So if you add them all together, you can just leave it like that. That'd be fine for now. The key is just understanding you need to do this as two integrals. So we're given a velocity function here, and we're given an initial position. Find the formula for s of t. So we know that when you integrate v of t dt, you end up with s of t plus a constant. So let's integrate negative 16t plus 32. So what's that going to be? It's going to be negative 16 over 2t squared plus 32t plus c. That's going to be our v of t. We've just integrated it right here. Okay, that's nice, but we want to find a formula, but we now know that s of 0 is 5. So this is, excuse me, that's not v of t, that's s of t right there. So when you plug in 0, you get 5. So s of 0, you end up with 0 here and 0 there. So you end up with negative 16 over 2, 0 squared, plus 32 times 0 plus c, but you know that equals 5. So what does that tell you? Well, that's 0 and that's 0, so c is equal to 5. So now you plug it in there. So our final answer, s of t, and I'll simplify a little bit, negative 16 over 2, it's going to be negative 8t squared plus 32t plus 5. And you can test this because s of 0 is 5. And when you take the derivative of this, you get the velocity. So let's do the same thing one more time. Let's integrate this velocity and turn it into s of t. So that's going to be 4 over 3t cubed minus 8 over 2t squared plus 12t plus c. But we know s of 2 is 3. So when you plug in 2, you get 3. So 4/3 times 2 cubed minus 4, 8 over 2 is 4, 2 squared plus 12 times 2 plus c, and that's going to equal 3. So if you do this out, you just have to be careful with the fractions, but you get c is equal to negative 47 over 3. You plug that in right there. So our final answer will therefore be the same thing we got before, the 4 over 3t cubed minus 4t plus 12t, but instead of plus c, we know it's minus 47 over 3. It's just the search for the constant. The lesson here is it's not necessarily going to be s of 0. It might give you something else. S of 2 is 3 in this case. So let's do one more for practice. Here's the derivative, and they want us to find f of x. So if we do the antiderivative of this, it's going to be 6 over 3x cubed plus 2x plus c is going to equal f of x. We know that f of 2 is 12. So f of 2 is 12. So f of 2 is going to be 6 over 3 is 2. F of 2 is going to be plug in 2 there, so it's cubed plus 2 times 2 plus c, and we know that's equal to 12. 2 cubed is 8, so it's 16 plus 4 plus c is equal to 12. So 20 plus c is equal to 12, so c is equal to negative 8. If you take that, you plug it in there, so now you know that f of x is equal to 2x cubed plus 2x minus 8. Right there, just searching for